Okay, hi, my name is Dion Robinson, and basically my project is called Fast API. I've been thinking about changing the name because I'm changed the algorithm that I was using based on some advice I got. Basically, what the idea is to create an image-based, image feature recognition database where people can upload images and get data based on the images. Basically, the idea is to create something like the same way you would create a browser and have web links linked to information on websites, have images linked to not websites, but something different. I'll show you in a second. So the problem is can you make an internet or a database of interconnected information for real-world objects? Basically, take an image and put information into that image, or get information based on the image from scanning it. Basically, my summer was spent building an application that does something like that. Basically, it lets you take an image and it scans it and it puts augmented reality interfaces, images, buttons, 3D objects, and video onto them. And I kind of ran into a problem that a lot of people I've seen are having. Basically, the storage of the device was the problem, and if this is going to be the browser, you kind of need the back end or the database end to store all the information for if you're building, let's say, a geocaching application or a augmented reality application. And there's actually been a lot of research and a lot of advances in this, mainly because of the speed of mobile applications. People have been creating faster and faster algorithms to do the image recognition, so it's become more and more feasible to create something like this. So the three different algorithms that I'm going to be using are FAST, Hessian, Affine, and Freak. FAST and Freak are basically really fast algorithms that have been written in the past 2 years for the mobile device, and basically what they do is they'll run on the mobile device, and Hessian Affine is basically what will run on the server to get information or get the key points of the FAST and Freak algorithms. Yeah, that's basically like computer vision stuff. So I mean, if you don't. So the progress so far. Basically, right now I'm running tests on whether or which algorithms that will be the fastest or most efficient to use something like this. Right now, I figure out that Hessian Affine was the fastest one. There's multiple ones that do similar things like serve, SIF, and things like that, and Freak was the fastest one compared to fast in terms of getting data and doing the feature recognition for the mobile side. So my to-do list for this semester is to create the rest of the image-based REST structure. Basically, you should be able to upload an image, get the data, upload an image, delete the data, upload the image, and update the data. I need to finish the system for storing the key points. The way it does image recognition is it scans the image, gets a bunch of points, unique points of an image, and it'll store it into the database. It stores two kinds. The Hessian Affine gives you different image points than the Freak and FAST algorithms, so you have to store each one in separate columns. And basically the image loader, which I've been having a lot of problems with, just basically can't get that to work again. So thank you to Morthy, Shauna Sullivan, and RCOS. Do you have any questions? Yes?
What sort of information are you trying to get out of the image?
I mean, basically anything you want to right now. Whether you want to create a mobile application and then use the database to store like related information for a geocaching application, or for me, augmented reality application, you can do that. If you want to, it's basically whatever you needed to do to store images as the ID for a certain set of information.
Oh, so you take a picture and then upload whatever information you want to store that links to that image, then other users, when they have the same image, get that information and go for it.
Yeah, and the idea is to have multiple people use multiple applications, so there will be one database or one server that does all this for multiple applications. So let's say I have one application, you create another application, we both have the access to the tied-in data for that. So I'll scan a Coke bottle, and let's say your users put information for that Coke logo in there, I'll be able to pull it out for my application. Anybody else that uses the database can pull it out for there.
What if you have conflicting interests in what you want to store in the data?
Right now, you'll be able to create your own subset of a subset database. So it'll be one global one. You can create one specific one for your application, one specific one for mine. But there will be one global one if you want to share all that different information. Any other question? Yes.
Okay. Sorry. So, if you're sending it back to the server, and the server does the feature detection, right? How do you do the classification on the feature detection to get whatever you want from your database?
I mean, right now you wouldn't need to do classification. Basically, it gets the key points, so it doesn't need to classify the information.
No, I'm saying like, okay, so you take a picture of skills and look, or moleskin, whatever it's called, right? And you get features from that, right? So how do you know which one's the moleskin, which one's not? You have to classify it.
I mean, it's not classified. Basically, what it does is it finds all the corners for an image. Let's say I take an image of the room. It'll find all the outlines for all the people, and then when everyone sits back down, and I take another picture of a different angle. Basically, just takes the outline and does the algorithm. Basically, predicts based on how much I rotated it if it's the same picture or the same people. It doesn't really need to classify it. It's more of storing points than storing like a classification.
So you're just doing nearest neighbors, basically.
What was that?
You're just taking your feature points and finding the nearest feature points and assuming it's the same thing.
Yeah. Based on whether you have a different angle or different like lighting or different situations, it should always give you back that same information. So whether a picture is in one room that's really dark, one room really light, whether you're to the left, right, or whether position, or whatever position, it should still give you that same information for it. Yes.
So is this something that's like you're meant to set up your own server, or is this something that you're going to run and it's going to have like a public API?
So it's open source, so you can create your own API, but I'll be running a full glue. Basically, what I want to create is a DNS or a backbone for people to create more like image-based like recognition software like this for mobile. Because they had problems and I had problems, and I kind of wanted to alleviate those problems for everyone to make it really easy.
Digital object identifiers.
Oh yeah, I looked into that. I still can't figure it out, but yeah. Yeah.
I think from one of your slides it looked like your server is running MATLAB for doing the processing. Is that
right now it could run MATLAB, but I changed it to use Play, and it's going to use OpenCV and JavaCV, which have all the algorithms built in. So.
How fast is that? How many images can it process?
That's kind of one of the tests I still have to do, but the thing with the Play framework is it's concurrent, kind of like Node.js, but it's built on Java and Scala, so it runs faster than Node.js and can do a heavier load or work with a heavier load than Node.js.
So when two people are labeling the object, right? Do I understand it correctly? You upload an image, you mark something, somebody else takes that image and marks something else on that object. Is that correct?
Yeah, I mean, if they want to, they can create another subset to mark.
Yeah, the only question is, what happens if they want to destruct or do something bad to that, make something bad?
Not sure. Yeah, I gotta think about that. Any more questions?